Hi everyone, hopefully this is going to be a short video. We're looking at, I'm showing you assignment 10. Things are slightly different from what I originally planned for assignment 10. I'm trying to make it a bit easier and a bit less intimidating when you have compiling errors. So let me point out a couple little things that we can do here. Well, first of all, I have a whole bunch of different functions here. I'm suggesting that I'm asking you to write a function called character shift 1400 that will take in a character coming in, how much you're going to shift it by in the alphabet, either to the right 3, 4, 5, 7 characters. So an A, if I'm adding 3 characters, A becomes B, C, D, it becomes a D. If I'm shifting the other way, a D becomes an A, right? Shifting to the left. So a +3 of a shift number makes A go to D, and a -3 in the shift number makes a D go to an A. You only have to do the shift to the right for the Caesar shift cipher. That's because going to the other way requires a little bit of extra fandangling. That's fine. But we have this Hail Caesar decrypt. That's how I decrypt a message. So I pass in a text message into this function, and what gets returned is another character array, a new character array. I'm going to use malloc on that thing to make it. I'm going to make a brand new character array, and it's going to be the decrypted message in that character array. So I'm not modifying my original message. I'm making a new character array and putting the decrypted message in that character array. I'll show you an example in a second. The hate Caesar decryption looks and does exactly the same thing. It should be identical in all cases. In fact, that would be a perfectly fine test, making sure that hate Caesar decryption gives you an identical message, as in the two strings, when you compare them, are identical to each other, compared to the Hail Caesar decryption. This is taking an encrypted message, a gobbledygook secret code message that you can't read, like the ones I gave you on the assignment, and converting it to human readable or English language, an English language message. So if you read English, you should be able to read that message. So I'm not saying it's universally readable for everyone, is what I'm saying, just for everyone in this class. We also I made a Hail Caesar encryption because I wanted to do the bonus question, which is going from a normal message and encrypting it. And so I actually have some tests in there, and I'm going to show you a demonstration of a test that really tests how the system works. I can just pass in any message. I will encrypt it, make it gobbledygook, decrypt it, make it back to my original message, and also decrypt it with the hate Caesar shift just to see it in action. Besides all of this, so here is that super array I was talking to about in the assignment, such that if the number of elements I'm keeping in here gets too big, you could enlarge the size of my array, which would require changing the dynamic array and changing the size that I'm keeping around. I have, and I also am going to be dealing with two different new structs called student1 and student2 data structs. One has a static array of characters, a name. The other one has a dynamic array of characters for the name. And then we have our free structures test, we have the size test, and we have the enlarge array test. This is my testing the array encryption. I have a message coming in. I am encrypting this. This is not required for the assignment, but I'm showing you what I'm going to show you when I run the code. I have a message coming in. I will call the Hail Caesar encryption message, which will make a brand new character array, and I'll put the message in. I will decrypt the message and put it into a character array. I will use the hate Caesar decryption to make a third message. This and this should be identical to each other. In fact, am I actually doing this? I'm also seeing that if I do a string comparison, that the message coming in is exactly the same as the message that got decrypted. But at the end of the day, when all of this is said and done, for my test at least, I called malloc a bunch of times. I made new dynamic arrays. I got to free those things up. This is me freeing up the encrypted message, freeing up the decrypted message, freeing up the hate message, and technically if I want to be really, It won't make a difference in here, but if I want to just get into a good habit, maybe I should put something like this. That variable is going to go away in about 2 seconds as soon as I'm done with this function. But, you know, for good habits, it might be a good idea. So you do something like this. When my array is given back, that pointer to that array should be set to null to make sure I never use that again, or I know it's actually freed. A. And null just means I'm pointing at nothing. I'm pointing at the air. It's actually equal to the number 0, but it's not a valid pointer, and therefore I know it's my way of knowing that I've freed the memory. All right, so let's compile this. Let's run it, and then I'm going to show you turning off one of the assignment parts. Let's say I have an error in my code and I can't figure it out. So let's run the code. Let's see it in action. There we go. Okay, here's my original message. Test encryption. Pretty wild, huh? This becomes... Notice the exclamation point and the spaces stay around. Here's the exclamation point. Here's the space. Space, exclamation point. Only characters, alphabetical characters, are changing. Now, I happen to also be encrypting and decrypting uppercase and lowercase. Also, you only needed to be able to support uppercase. I did both, as I said, as a bonus glory answer that you could do. So here is me encrypting the message. Here's me decrypting the same message. This was done by my Hail Caesar decryption algorithm. Gets me my original message. And here's my Hate Caesar decryption algorithm. The Hate Caesar decryption algorithm cannot use square parentheses. You have to use the asterisk or the ampersand, so dereference and reference symbols, but not the square parentheses, just to give practice. It's exactly the same algorithm. I'm just showing you that they are equivalent to one another and to get you some practice. All right, and I can deal with something with here's me making a brand new array and doubling the size. I think I started at size 10 and doubled it. Here is I don't want to be giving away that answer, and I'm doing a name test with John Smith. Okay, that's the kind of thing you would expect. It's essentially 4 completely independent tasks. Let's pretend my Hail Caesar encryption algorithm does not work as expected. So let's see if I can find that. Go to definition. All right, here's Hail Caesar. So I just made a more general thing called shift message. Let's do the Hate Caesar encryption message. Actually, I don't want to give answers here, but how would I do this? One thing I could do, I could put one of these in front. I'm going to try and go past it very quickly so you don't see the answer afterwards. Put one of those at the bottom, and boom, it's commented out. If I go to compile it, what's going to happen? It's going to yell at me. Every time I call this Hate Caesar encryption algorithm, it's actually not defined yet. I want to go up to my definition up here. Notice it's undefined. It's giving me a warning. And okay, it's undefined. All right, this is where my errors are. I got a bunch of errors. Notice, hopefully some of the times it'll figure out what the heck is going on. I'll get a red line underneath it and I'll say, oh, that's the problem. The function is not defined. Sometimes it's a green line underneath it. But what I'm looking at is I can go to where this error comes in, line 41, and I'm looking around for what could possibly go wrong. If I get something like this and I know I've defined Hate Caesar decrypt, I'm checking the spelling. I'm checking why the heck this might be wrong. Are the parameters wrong going in? Is the spelling wrong? Is the thing being returned the wrong data type? That's what I'm looking into. So if I've commented out my code, by the way, I might do something like this. I might do something like, oh, I'll comment out this line next as well. I don't want you guys getting stuck with just a compiler, and that's why you couldn't finish parts of your assignment. So I can sort of excise or remove chunks of my code all in one go. So remove this one, do this one, and I think that's all. I'm going to just check now. Great. What else could I have done instead of using this slash, my comments? For those of you that want to get all cutesy on this, let's see here. Character shift message. All right, here we go. I could do something like this. And the reason I want to show you this is because very, very soon, if 0 and if, we'll be looking at pre-compilation instructions. That pre-compilation instruction there says if 0, if false, essentially, so it's never true, then go into this. Otherwise, remove it. At the end of my if statement is at the very bottom there. So if false is true, never is, do this, include this code. Otherwise, don't include it. I may have said something like else, and then I could put in another version of my function, for example. These are pre-compilation instructions if you wanted to try those out there later on in the lecture series. But it's yet another way that we can comment out large chunks of code at once without necessarily, if you have a whole bunch of those open and closing block comments, there's another way to comment out a chunk of code at once. Okay, I'm hoping that makes sense. The idea is we have 4 different tests. Only 2 of them have to compile. So if you get stuck anywhere, comment out that block of code. You can still write the code. We'll still review it. We'll still read it. We'll still grade it. It just doesn't have to compile. So if compiler errors are getting in the way of you being able to do your task, put down some pseudocode, put in a block of comment, and we'll grade it. But 2 of them have to work. Okay? And I'm hoping this helps reduce some of the workload. If you can do all 4, we'll take your top 4 for the ones that are running. So, or the top 2 for the ones that are running. So it doesn't hurt to have all 4 in, but if you get stuck, comment out the code, but you can continue working on it. Okay, I'm hoping that's helpful, and let me know if there's any problems or if there's any kind of confusion with assignment 10. Thank you very much. I hope this will be helpful in some way. Thanks.